Okay. Let's finish off then. Try and get this done in half an hour because I've got. Okay, number 5 out of 10, real-time web maps. Okay, what's a real-time map? Well, unsurprising, it's live data streamed from sensors, GPS transmitters, web feeds, you name it, anything pumping out live data. But I guess the question is, what does it actually mean to be live? Is any delay permissible between something being detected by a sensor and it being disseminated over the internet? Or do we accept some kind of delay? I mean, there has to be a delay because there's a delay between the thing recording something and it arriving at the server and being available for the server. But that could be milliseconds. But quite often things are batched. They're collected once an hour and then an update is done once an hour. Is that live or is that not? Depends, I think, often on the context, whether you think it's live or not. Okay, so is any delay possible? I've got another question here. How long is now, if you understand what I mean by that? Okay, I've just looked at that earthquake map, that hazard map, and it's showing me what's going on now. But what is now? The earthquakes have clearly happened. You know, an earthquake lasts a few seconds, maybe a minute or so at most. So what is, when we look at a map that's a live map, it's clearly got different time periods. It's covering a time period. It must cover a time period. So the question is, how long is that time period? And is that time period, at what point does the time period become so long in relation to the thing that's being modelled that we can no longer call it live? Here's another S31, the 1 million tweet map. It shows you the geographic location of the last 1 million tweets. There we go. How long is a million tweets? Is it a second? Is it 5 minutes? I've no idea. Probably depends on the time of the day, perhaps. I've no idea. Anyway, live Twitter feeds, live earthquake feeds. How long? And indeed, when I was making this map, I probably haven't got it here, I actually had a new one appear as I was refreshed the map and I got a new earthquake. It doesn't matter. But what I'm saying is the difference in time delay and the period that's being shown is going to differ between these two maps. Both are live, but both have different temporal periods and probably delays in the information getting through and becoming live. Personalized maps, number 6. Basically, this says the user can customize the map to their needs without the need for programming experience. Basically, point and click, anybody can go on and make their own map. And the things that people might do, turning layers, toggling layers of information on and off, choosing color schemes, adding their own information on top, adding titles, that kind of stuff. In a user-friendly interface. I mean, it doesn't have to be user-friendly, but preferentially because you're providing these services to non-experts, although these can be. So Digimap, you're all familiar with Digimap, I hope by now. Digimap has a service called Roam, the Digi-Roam. So where's Roam, where's Roam? Yeah, probably right at the top, little blue right in view. So if we click on that, the Roam allows you to access the Ordnance Survey data through a quick web interface. You can turn on various layers in the overview map. You've got a key there. We've got the Ordnance Service back mapping. I put a circle on and I put some text on my map. That's a personalized map. I can now download that, put it as a PDF, send it to my friends and colleagues or whatever. So that's an example of a personalized web map. Look at all the options that we've got for colors, shapes, text size. You know, we can actually select items, we can draw them, we can modify them. We can do quite a lot in this map interface. So that allows us to make a personalized map. Interactive maps was number 7. Basically, an interactive map allows the user to interact with the data displayed on the map. When Clark first wrote the classification, came up with the classification in roughly, well, it's nearly 17 years ago, 18 years ago, interactivity was relatively new on web maps. A lot of web maps weren't very interactive. That is not the case nowadays. In fact, quite the opposite. I would say most web maps are now interactive or have a degree of interaction. Things like information pop-ups, personalization of the map is that you have to interact with the map to personalize it. Maybe done some kind of analysis like route finding, something like that. Maybe it involves collaborating with different people. That requires interaction. So most web maps are now interactive. I also wonder whether there's any interactivity that isn't classed as interactive, if that's not a sort of, what's the word for something that's logically inconsistent. But for example, the static map interface to the Library of Congress allowed me to pan into the to zoom into the image and pan across the image. Now, I don't think that's interaction. I wouldn't personally define that as interaction because I can't interact with the data displayed. I'm just interacting, zooming into an image. I can't interact with that image except by blowing it up, moving it from left to right. Now, you might want to argue against that definition, but I kind of go with that as a definition of interaction. Basically, I discount panning and zooming on images as interaction, but others may think elsewise. So I don't have an example of an interactive map because we've just seen one, and most of the maps that we've seen have been interactive. In fact, they all are if we include panning and zooming onto images, but I don't. Okay, number 8, analytical maps. Support some kind of analysis, use spatial analytic function, route finding, overlay analysis, buffer analysis, some kind of analysis. This is an old one. This goes way back. This is probably one of the first examples or an early example of an interactive web map. To a certain extent, you can see it's old just by the sort of the styling of the page and the box and everything. It's all a bit primitive. It was designed, as you can see, for Center County in Pennsylvania, and it's just a simple land information system. Basically, the user accesses the map, goes to where they want to get information on, clicks on the map, and a report is generated, or point in polygon or point in proximity analyses are run that provide a report on that location in respect of things like land use, whether it's on a floodplain, types of geology, soils, and things like that. This is exactly what happens. So if you've ever bought a house, you need to get you need things like flood risk maps. You need for your insurer, for your mortgage provider, and there are basically the companies that provide. Basically, you have to sign up to a company that has software that does this sort of stuff for the UK, and they generate. You've paid them 250 quid to produce a report on the geography of your house for your mortgage company, from data that is generally freely available. So I could produce exactly the same report from the freely available data that the insurance companies use to produce it, but I'm not allowed to do that when I'm buying a house because I'm not an accredited person for making that report. So this is the sort of stuff that goes on absolutely every day. And we can see that here we've got residential forest, not within a 100-year floodplain, no streams within 200 meters of the spot, all that kind of information. So that's an example of an old analytical map. Route finding on Google Maps is another type of analytical map, web map. 9, nearly there, online atlases. So this was the new class put in by Neumann, 2011, roughly thereabouts. And it's basically defined as a collection of different web maps grouped by theme or topic. And he states in that paper that there is great variation in the size of these atlases, the degree of interaction that exists within these atlases. So here's an example of what I think of as an atlas. It's not just an atlas of spatial data. It's although spatial information is obviously quite important to it. So this is the Living Atlas of Australia, which is an interface into the biodiversity data, biodiversity information and collections held by the Australian states and museums and things like that. So I'm going to go in quick journey. We're going to species by location, provides me an interface that allows to explore by predefined regions, administrative regions and things like that, but also by geographic regions, marine regions, management zones, all that kind of stuff. And also by address or location. So if I'm going on holiday somewhere, I can type in where I'm going on holiday and get a set of information back about this. I must say, one of the reasons I'm showing you the Atlas of Living Australia, that it is recognised as one of the most advanced such systems, certainly for biodiversity information in the world, and they're sort of leaders in the provision and of biodiversity information in Australia. So I'm going to go in, we'll go by predefined region. Got a whole variety, huge number, I mean really good selection of choice of various regions. I chose the indigenous protected areas. I get my map up. I chose Birriliburu, which is here. Unfortunately, I couldn't point and click on a map, and just because I wanted one of the nice big ones, not one of these tiny little ones down here or right down here. So it took me a little while. I wanted to click on the map and be able to highlight the area that I was in from the map, but I couldn't do that. So that was a limitation of the interface. But I went to Birriliburu, select Birriliburu, whatever it was, Birriliburu. Okay, so I clicked on that. So Birriliburu. So I get we zoom into Birriliburu, and we've got the point map of all the locations where species have been recorded within there, and we can see that we've got 7 records of Acacia burkitilil and various other organisms. I want to go into some more detail. I'm interested in mammals. I want to see an egg-laying mammal, never seen one in the wild. So what monotremes are there in this area? Monotremes are egg-laying mammals. Well, there we go. We've got 1 record of egg-laying mammal, so I can go and that is where a short-beaked echidna has been observed or collected in that area. So there I am. I'm off to see my short-beaked echidna. So nice interface, relatively easy to use, provides lots of different information. Oh, and then I want to know, well, where else can I see this echidna? So I select on the echidna, and suddenly I've got the data from the entire of Australia for the echidna, and we can see see what the location, the distribution of the echidna. Is there anything is there anything about that map that's a bit odd? It's all on the coast, not surprising. Most Australians live on the coast, yes, and so most surveying goes on in the coast. Anything else? There's data for Papua New Guinea. Okay, yeah, good. Yeah, I think that there's a close connection between Australia and Papua New Guinea. Papua New Guinea was effectively an Australian colony, I think, up until about probably the 70s, or even early 80s. Anything else? Well, one thing I notice, that long line is almost certainly a road. Sampling along a road, most sampling will go along the road. Also, Western Australia clearly has a far less intensive sampling than the rest of Australia put together. Now, I'm not aware of there being a huge difference. I mean, it's all desert as far as I know in here. So it's not that this is incredibly horrible desert. Well, it probably is, or a harsh, better word than horrible. And this isn't. It's just the fact that maybe these states have undertaken a far more detailed biogeographical surveys of their flora and fauna, have spent more time integrating the data and making it available than Western Australia. Also, of course, the main population centres in Western Australia are down here in Perth and Fremantle. Basically, there's no other large population centres in Australia. So if you're interested in Western Australian flora and fauna, you've got an awful long way to travel across very harsh environments before you're going to be able to sample this part of Australia. This is just an aside. It's nice to see these things when we see maps. Okay, collaborative web maps. Number 10, maps created by community of some kind of description. This is linked, or collaborative web maps, often with crowdsourcing and the concept of volunteered geographical information. We got a whole lecture on this in due course on crowdsourcing VGI. The most famous collaborative map is probably the OpenStreetMap initiative, the attempt to make a global street level map, open street level map for the entire world. And OpenStreetMap has been in the news quite a lot over the last, I would say, 7 years, well, roughly since 2010, 2011 in particular. I'm talking outside of the geospatial news, but in the general news. And one of the times it was the Haiti earthquake. So here in this article says the first disaster in which open source online platforms have been heavily utilized. So that was in 2010. So the Haiti earthquake, so here's a few examples of what happened in the Haiti earthquake. So this is before the Haiti earthquake. This is the state of OpenStreetMap for Port-au-Prince, the capital of Haiti. And a matter of couple of days, 48 hours, 36 hours after the earthquake, this was the open source map. As you probably know, groups of volunteers organised themselves. What's the one in the UK? I can never remember what it's called. Map Action is the main organisation in the UK. So when a disaster occurs, something happens in the world, the volunteers are called in, or they get a call. They try and update the information that's available and provide mapping support to disaster relief. So one of the things that they did was clearly to make the first decent open source base map of the whole country, particularly Port-au-Prince. Also, there was assessing of damage from remote sensing imagery released by various companies, satellite companies, or people who own the satellite imagery, which normally wouldn't be released, were released within 24 hours, and then people could look at these grid squares and assess the relative damage in each of them, which is then forwarded to the relief teams who decide where to target their relief efforts. They also what was set up was local reporting systems like this, so people could report various things that needed dealing with. In this case, unfortunately, it's a dead child, the location of a dead child being reported. So mobile technology is being used to assist local reporting. And also mashup maps, so various organisations, there's lots of different rescue organisations operating in an earthquake relief, plus you've got people around the world providing this additional support information. And the US State Department of Defense Southern Command produced a mashup map of watch this is an example, which brought together a whole variety of these different data sources in one place. And as it says here, this mashup map provided a common overview of the disaster and disaster relief efforts, and became basically a talking point, a place around which people could gather to talk about what was going on, who was doing what, and what needed to do. So it very much became a focus for communicating and between organisations. Okay, Australia again, quickly. So this was one of my previous examples, and this is a social health atlas of Australia in this case. And here are the various classes that we've got: static, dynamic, distributed, animated, real-time, interactive, analytical, atlas, or collaborative. And just to say which, just looking at that image, which classes do you think apply? I mean, I know it's not much to go on. I do realise that. Interactive, clearly interactive. Yes, there's a selected area. We can select from here. It's clearly interactive. Yes. Atlas. Yes, it provides a set of information. It calls itself an atlas. That doesn't actually mean it is an atlas, of course, by our definition, but it provides an integrated view onto a set of social statistics. Yes, probably an atlas, yeah. Analytical. Why do you say analytical? That's just the scale. That's the legend being used. Yes, so we've sort of burrowed down to a particular set of data. Do you think that's analytical? It has a histogram. Is a histogram analytical? What was the definition of analytical, Matt? It was a pretty wishy-washy definition, I'll give you that. That's interactive. What is an analysis? This raises the question, what is analysis? Yeah. So what the reason I put this map up is this very, very question. I don't know whether to class this as an analytical map or not. To me, it comes under the umbrella exploratory data analysis. Okay, so there's two sides to analysis. There's quantitative analysis, distances, calculating routes, distances, percentages within areas, and all that kind of quantitative analysis. This doesn't support any of that kind of analysis as far as I'm aware. I can't do a linear regression of one variable against another. I can't do a buffer function. I can't do any of those, what I would call classic analysis. But I can undertake, it's about visual analysis, it's about exploration, it's about pointing and clicking and selecting subsets and looking at the visual presentation of that. These are all obviously linked. So so I've got the Tennant Creek area highlighted. That line there is that record in this histogram here. And it would also be highlighted over here. So it's an example of as I say, an exploratory data analysis tool, but I think it all depends on what you define as being analytical, whether that would be classed as an analytical map as not. It's certainly not static. It's dynamic in that it's recreated each time because it's getting data out of it. It's not a static image. Distributed, we don't know off the top of my head. Chances are it's just on one server, I guess, but it could be on multiple. You'd have to look at the metadata and the information about the database to find that out. Animated, not as we see here. There may be facilities to annotate somewhere else in the system, but we're certainly not looking at them here. Real time, no, it's a historical data set. Interactive, yes. Analytical. Atlas, yes. Collaborative. Collaborative. Yes, no? No, because you can't add anything, yeah. I mean, it's been collated, presumably from the health statistics collected by the individual states and the individual health of however the Australians manage their health system. But I would say that is not sufficient to be regarded as collaborative, just that the data has come from lots of different places. I think you're right that it's the idea that I could go, or at least edit that. But there are also closed groups of collaborative maps, so maybe you just got to be. But yeah, you can't add more data to it, I think. I agree. Okay, so that is classification. Newman, in the Encyclopedia of GIS 2008, provided this alternative classification, or at least properties data. And I prefer this. I think this provides a much clearer differentiation between, or way of thinking about function of web maps, and what they do, how they operate, and what their functionality is, and what their usage is, than Crack's list of 9 or 10 objects. And I think it's interesting to map those Crack's classes onto this view. So basically, we've got an arrow here from versus, that says versus, can't say I like that graphical arrangement of letters. But basically, we've got a trend. This is about trends, and it's a trend of increasing sophistication. So up the top there, we can see that the contrast here is between static and animated. Is it a map relatively stationary and not moving, or is it changing and moving? I think that's an easy thing to differentiate to me. Does it change? Does it animate? Or is it the same? Does it not change? I can tell that easily. Is it view only? Can I just look at it, or can I interact with it? I'm not sure what document-based versus application-based means. I'll just have to look that one up. We've got static files, as in files hard-coded, within just maybe a text file, versus dynamically created access from a web database, or extracted from a web server. I can understand the difference between that nice and easily. Is the data static or infrequently updated, or is it updated in real time, weather, traffic maps, things like that? So it's a scale between the data being not updated ever to being updated occasionally to being updated almost in real time, or as in real time as you can get. Is it predefined, the content and the styling, or can you personalize it? So I like that. Also usage, is it for a broad general audience, or is it for a narrow expert group of people? How accessible does it need to be? How much does domain-specific language used? So I think I prefer the Newman view. Okay, so that's pretty much it. So what did we learn? We learned the World Wide Web runs on the internet, and the Geoweb is simply the part of the web that's concerned with data and applications. We've seen that there are lots of different types of maps on the web, and we've seen that Clark's classification, well, has lasted nearly, a decade plus. So it's reasonably resilient, given it's the only real it's one of the few classifications out there. The only other one I'm aware of is this Neumann 2008 one. But to me, it's a bit of a ragbag of characteristics, rather than what I would call a proper classification. There's something very unsatisfactory about the difficulty in defining things, and the fact that they're not clearly differentiated from each other. Whereas I think Neumann's properties of a map, I find that much more intuitive. I can easily put a map somewhere on the scale between those two endpoints of those various things, and I prefer that. And finally, I wonder, are we not just talking about digital maps in general here, rather than specifically web maps? It should be web maps, obviously. So this is sold as a web map classification. But to me, that classification could be applied to any GIS map, whether it's on the web or not. It's just a digital map classification. I don't know whether any of you think that ever think about that. Think whether you think there are things about the web that make it a web map classification rather than a digital map classification. I can't see anything myself. So, now 1:30. So we meet again in about just over an hour, roughly. Half an hour, not an hour. So what I'd like to do in the practical is I'd like you to try and find, or between now and maybe about 4:45, 20 past, so within let's say in roughly an hour's time, we gather together and have a look at some of these web maps. So I'd like you to try and find one each of Clark's map classes. Now you might not get one of each, just try and find a few examples, some interesting examples. In the practical, we'll have a look. We'll go round and each stick one of our maps up. We'll talk about how well the map fits the various classifications that Clark's classification, or indeed we could think of Neumann's properties thing as well. We can in doing that, I'd also like you to, what I'd like you to do is to create a table, effectively organize this as a table of map class examples. And when you do your web map HTML and CSS, one of the exercises I suggest you do in making a table in HTML, a web table, is to put this data into a table. So I suggest you keep it for that, just as it's a handy thing to make a table with a nice example. But as well as doing the classification and identifying which maps fit various classes and how well they fit those classes, I want you to sort of step back to a meta level, so to speak, an overview level, and say, look at the various those 10 classes and say, are there any constraints or relationships that exist between those classes? If you're a member of one class, are you automatically a member of another class, or are you automatically not a member of another class? Are certain combinations of classes impossible and certain ones possible? So I want to think about that the overlap between definitions, whether the definitions are the classes are truly independent of each other or not, and to actually try and well, I've told you that they're not independent of each other, but can you tease out from looking at the definitions of the classes what those relationships in that taxonomy are? Okay, is that clear, reasonably clear? All right, so let's say if we meet, so roughly aim to start our discussion in roughly an hour. So maybe about 22. So that gives you just over an hour for a break and to find some web maps. Yep. Happy? Happy, good. Good. It's a good discussion. I like the web map discussion. It can be fun.